Okay, in this video I'm going to talk about a transient analysis in LTspice. I'll try to make this one a little bit shorter because I think we've done it a little bit in some of the other videos. In this particular case, I've made this op-amp symbol and I've made this into an ideal op-amp. You see there are no power rails, so I don't have to worry about hooking up power. In a real op-amp we do have to have power. And in another videos on how to do a sub-circuit, you can learn how to do that. And that's why I have this .include statement here. So I've set up this circuit and we have our voltage source, and I've set this up as a sine wave. You could use some of these other things, but the transient analysis could be, I guess, used for DC too if you have a transient. So I already have tran 2M set here. If I hit run without anything down here, it is going to ask me what type I want. So let's get rid of this. Or actually this will be the menu that we would see. So if I didn't have anything, we would see this menu and we can select from the different ones. We've looked at DC operating point and we've kind of looked at this and we see we need to at the minimum have a stop time. How long do we run our simulation? So I've got this voltage source set up for a 1 kHz frequency. So if I take a look at that would be the period would be about 1 millisecond. So I put 2 milliseconds to get about two cycles in here. So let's go ahead and run this, and we get this. Now we can just run our probe down here and we can see we get an output. And this is when whenever we run a sine wave or something like that, we want to see that kind of an output, we run that transient analysis. And so it's kind of counterintuitive. It seems like we should run an AC analysis, but that's not what we want. Now, one of the things you'll notice here is we kind of start out at 0 and we go up and down, and we're not going down to the same amount, and then we're up a little higher. So what's going on there? Well, we do have some transients. It hasn't settled down yet. So how do we take care of that? Well, I right click down here on my simulation command, and we can see we say start saving data at a certain time. So maybe we don't want to see anything before about, say, 4 milliseconds, and that gives it a chance for everything to kind of settle down. And then we want to say let's stop saving at 6 milliseconds, and that'll be our 2 millisecond time. Here's the syntax if you ever want to know what you need to put down here. You got a couple other choices here, but let's just look at it this way now. So I'm going to run this again, and let's see if we get a better signal. Oh yeah, so that looks a lot better. So here we are. This is really starting at 4 milliseconds, and here's 6 milliseconds. Now we have a nice little wave there. We can also let's compare that to V1. What does that look like, or Vn? And so we can do that. If we want to look at some currents, a couple things here. So let's look at a current. We need to notice that, hey, this is our current scale over here. We could do a couple things with the scale. I can right click that. I can change the top and bottom of it, the number of where the ticks are. I could change to a logarithmic scale. Same thing here. And I can also make some changes here if I want to do some different things here. So just be aware that you can do those things. And let's see if there's anything else. The other thing too, it doesn't matter so much when we're doing AC, but notice which direction our current arrow is pointing. So sometimes if you get something, you think the phase is one thing and you realize, oh wait, I wanted it going in the other direction. So in order to take care of that, let's say we wanted to know what IR3 here was in the other direction. I can right click that and I can just go over here and put a negative sign in here and hit OK, and then it will change it. So a couple of other things that we can do is we can go up here and right click on this menu bar. We can add more traces, and let's see what that looks like. So here are all the different things that are in here, but we could also type an expression. We could say Vn over V out, or Vn minus V out, or anything like that, and it could plot for us. Okay. The other thing too is we can right click on this, and we saw here we could delete this trace, so let's delete it. But now let's right click on Vn, and let's look at this. So I can put a cursor on here, I could say cursor 1, I want to be on VN, which is the blue. And so I move my mouse up here and I find my cursor, which is there. And now I can move it and see how, it's hard to tell, but it's only moving on the blue one, VN. And when I do that, this pops up, which is just off the screen here. And we can see that I can move to different places. I could try to kind of find the peak point, let's say, and look at that. And let's just see if I want, let's see if we can find that peak right around there. And best we can do maybe is there. And let's go up here and say, we want both cursors, 1 and 2, associated with that. Now we can find cursor 2 right here. And let's put that on the peak over here, and then we should be able to find out what our frequency and period is. So we have cursor 1's information, cursor 2 information, and here's the difference. So our frequency, we set it up to be 1 kilohertz. So yeah, that looks pretty good. And we can see there's our 1 millisecond. That is our period. And we could see a couple other things there too. The other thing we could do is we could say, let's put V out on cursor number 2. And then we could compare some things there. So we've got cursor 1 there, and let's see if we can find cursor 2. It's those real tiny dotted lines. But now you see this one's running along the magenta colored one. And we can put that on the peak, and we can kind of see what the difference there is. So that's one of the things you can do. So I think I'm going to wrap it up there, and then I'll do another video on some of the other simulation types you can do.